how to find the slope of the tangent line at x equals a. Yesterday, we used that guy a lot, didn't we? And we found out how to do quadratics, square roots, and fractions. And we did it with numbers, and in this case, we did it also with letters. And that is my go-to method. If I have to do it, officially or kind of the logical way of doing it, this is the process. I use what I'm going to call method 1. There is a second method called method 2 that gets the same job done. And in the homework, you're asked to do it definitely once. That might have been, you might be asked to use this method a couple of times. And so I need to show you. It's not my go-to method. I don't really like it as much as the top one, just because it tends to be a little bit uglier when you do quadratics. It's quite nice actually for radicals, right, for square roots. And I'm going to show you how to use this method in both those examples. And then after that, we'll talk about finding the equation of a tangent line. And then after that, I'm going to show you how to cheat. I'm going to show you a shortcut for just polynomials. Right, so let's look at this method and kind of see what's happening. So here is the function, the green guy, right? Y equals f of x. And I'm interested in the tangent line at P, right? When x is a, right? This point P, probably some line like that. And what do I do to try and get there? Well, I pick another point Q. Do you notice that the coordinate for Q isn't a plus h anymore? I'm just calling it x. So that's a little bit different, right? I mean, I could call it any letter of the alphabet, but we typically call it x, right? And Q then has coordinates x, comma, f of x, right? Just like this guy has a, comma, f of a. And I'm going to find the slope of the line, the secant line, PQ. And it's the rise over the run, the rise over the run. The difference in the y coordinates then, divided by the difference in the x. The difference in the y coordinates is f of x take away f of a. The difference in the x coordinates is x minus a. Now, can you imagine the secant line joining P to Q is really not that good an estimate? But what's going to happen if x gets closer and closer and closer to a? Just like we did the last time, right? They come together. Now, when P and Q come together, isn't the slope of the PQ going to essentially become the same number as the tangent line? So what we do is we take this fella and we find out what's its limit as x tends to a. And that guy will be the slope of the tangent line at a. So that's the theory of where this formula came from, right? We did a similar kind of picture to prove where this formula came from. Here is the formula, or this is how this formula comes about. Now, yesterday I did, using this technique, a quadratic, a square root, and a fraction. And I did it with numbers, and then I did it with a's, right? This method, I'm only going to do a quadratic and a square root. And secondly, I'm only going to do it for the a's and not the numbers, right? We got a time issue. If you can do it for the a, you can do it with a number, right? So let's see how to apply this new guy. So let's suppose I have a function x squared plus 3x minus 2. And I'd like to find the slope of the tangent line at x equals a. And that's the shortcut, isn't it? That's how you just say it, right? Instead of having to say the slope of the tangent line to the curve at the point x equals a, you call it this guy, f dash of a. So, also called the derivative of a. So it's going to be the limit as x tends to a of f of x take away f of a all over x minus a. F of x is this guy. So x squared plus 3x take away 2. Subtract f of a. What's f of a then? What is it equal to? Don't overthink this. What's f of a equal to?
Substitute in a for x.
And you would get that guy, agree? Why am I putting brackets around all of this next to the minus? What's my reasoning behind that?
You're going to have to distribute that minus later.
Right, so it's just so I don't screw up, right? So sticking a bracket around it just helps, right? You're going to distribute, as Sabrina says. So it's going to be the limit as x tends to a, and it's going to be x squared take away an a squared, plus 3x take away a 3a, but -2 take away a -2 is -2 add 2, the numbers disappear. So when you do this method, you're going to end up with a fraction. You end up with a fraction in all of them. But the top will not have any numbers in it. So if you do one of these questions and there's a +3 left over or a -2 left over, right? Something like that, stop. You've screwed up. Go and figure out what went wrong, right? It never has one. Remember when we did the h tends to 0, don't you get to a line where everybody in the top has h's in it or has to have it? There isn't any +2s left over either, right? So the numbers will disappear in these questions. One of the reasons I do not like this method is coming up right now. We have to factor that expression. It has to be factored. It's not a very obvious factoring. In fact, it's not even really going to be done in one go, which is what you typically do with factoring, right? Two numbers multiplied together give you this, but when you add them, you get that. You know, that kind of process. It's not going to be like that. Yet at the end, I'm still going to factor it. Take the first two guys. That's this two. And I'm doing this really slowly. And take the next two guys and pull out a common factor of 3. Right. Now, I normally would never do it with this many lines, but I don't want to do too much in one go in case you kind of lose the place. Now, only x squared minus a squared. Forget everything else in the top. Can you factor x squared minus a squared? Do you recognize it as a difference of two squares? So you factor it. Now, if I was doing that, I'd be going there to there, right? I wouldn't be doing that line. Now, we're almost there. Do you see this expression is made up of these two guys multiplied together, plus this expression is made up of these two guys multiplied together. Do you see that they both share a common factor, x minus a? So I'm going to pull out that x minus a as a common factor. And here it leaves behind an x plus a, and here it leaves behind a 3. I have now factored the numerator. Can you see that you had to do a kind of special technique to factor it? It wasn't a normal x squared plus 4x plus 3 kind of thing, right? Bit clunky. But the good news is, hopefully you can see it, is there anything I can cancel?
The x minus a.
Which means that this becomes the limit as x tends to a of x plus a take away 3. Great. Technically over 1, but if it's over 1, it's not a fraction, so I won't write it. What do I do next? We're almost finished. What do I do next?
Is that x plus a minus 3 or plus 3?
Did you? Oh, let's check which it should be. It's plus 3. Yes, plus 3. Okay, what do I do next?
substitute a in for x.
Okay,
Well,
yeah, nailed it. Exactly what you should do. There's your answer. You know, when you do limits, if there's not a problem, can't you just replace the x by 4, the x by 7, or in this case, the x by a? So, that guy is this. So if I wanted to, for instance, find the slope of the tangent line at 3, wouldn't the answer be 2 lots of 3, add 3, 9? And if I wanted to know the slope of the tangent line at 10, it'd be 23. And the slope of the tangent line when a was 70 would be 143, and whatever else you ever liked. Because once you know that, don't you know this tangent line at any point that you want, any point on the curve at all? Okay. Would you agree that it's a little bit more awkward, at least the factoring part is, than an h tends to 0? If you did an h tends to 0 one, in my opinion anyway, it's a lot cleaner, a lot easier to keep. So if you do homework questions and they ask you to find f dashed of 4 or f dashed of a, and they don't mention method 1 or method 2, which in most of the questions they don't, you're totally allowed to use method 1, h tends to 0. But not everyone's the same. Maybe some of you are just going to like method 2 for whatever reason. It makes more sense to you. I have no problems. Use method 2 then. It works. You'll get the same right answer. So here's my second one. Let's find f dashed a, right? The slope of the tangent line at x equals a for this fella. So that's going to be the limit as x tends to a of f of x, take away f of a over x minus a. Method 2 is quite clunky for quadratics and polynomials, right? It's just messy. It's actually not that bad for square roots. Atrocious, absolutely atrocious for fractions. Don't even think about using method 2 for a fraction. You'll just get a headache, right? Trust me, it is not pretty. Just don't do it. My advice, just don't do it. Right, back to this fella. It's going to be the square root, oops, I'll turn it in space, there we go, of 4x plus 1, take away the square root of 4a plus 1 of over x minus a. Are you all happy about f of x, take away f of a? Right, not that hard to do. F of a is the square root of 4a plus 1. F of x is essentially itself. I hope you have done enough limit questions that when you see a square root like this, aren't you going to think conjugate method? Would you all agree? It just is. That's the go-to guy. So it's going to be the same two guys, but with an add. So it's going to be the limit as x tends to a of x take away a first guy plus second guy. Okay, when you multiply this with that, you could do it by FOIL, but can we just do the shortcut? Isn't the shortcut first guy squared, take away second guy squared? And if you square this guy, you get 4x plus 1. Take away, if you square this guy, you get 4a plus 1. Do you see that bracket thing again? To make sure you subtract both terms, right? You distribute the negative. So what you're going to now get is the limit as x tends to a let's see what the top looks like. 4x take away 4a, plus 1 take away 1. Oh, that's all we get left. No more numbers, right? Just x's and a's. Good thing. I need to factor the numerator. There's no alternative. I got to do it, or else I won't be able to simplify this anymore. Would you agree that 4x minus 4a isn't really usable in at least the way it's written? So what kind of factoring can you do? It's not a great factor, but it's a factor.
You can pull out a 4.
Agreed. Agree? Common factor of 4. And just like magic, can you see a cancel? Which means we are now looking at the limit as x tends to a of 4 over this guy plus this guy. Now, you know how this is going to finish. Aren't you just going to replace the x with a and tidy it up? Right? So we're going to replace this x with a. That's essentially, just evaluate. And that's going to get me the square of 4a, the square root of 4a add 1, plus the square root of 4a add 1. Okay, let's do style points. Anything you can do here to make it look a little bit prettier?
Just make it 2 times square root 4a plus 1 instead of
Agreed.
1 plus another.
Yep, agreed. Sometimes you're finished, but not this time. Anything we can do to make it even prettier? It's not a lot.
Divide the numerator and denominator by 2.
Yeah. And I like that answer. Would you agree it's quite a nice, pretty answer? Could I rationalize the denominator? Sure, but wouldn't it look uglier rather than better? You know, if I rationalize the denominator, it would look something like this. I mean, look at the two. Is it nicer, uglier? So, leave it like that. So far, so good. Method 2. You can use it to find the derivative of numbers. If I wanted to, if I had time, couldn't I do f dashed of 4? Wouldn't all I would do here is make the limit as x tends to 4, right, and just replace the whole things with numbers. And at the end, I'd get a number, right, and that would be fine. So what we're going to do now is show you how to find the equation of a tangent line. There's quite a few questions in the homework where they ask you to find the equation of a tangent line. So let's show you what one would look. I'm going to use this guy, that way I can kind of save some time. So suppose we have a function, and I'm using the same function as here, and it's x squared plus 3x take away 2, and we're being asked to find the equation of the tangent line. At the point P, oh, what would that be? 2, 2, 4, 10, 8, at 2, 8. So, can you pretend that I actually know what this curve looks like? It looks something like that, right? Just for argument's sake. And can we also pretend that that's 2? Can you imagine that's the point P with coordinates 2, 8, right? When they're talking about the tangent line, right, that's this red line here. What they're really wanting to know, and I'm making this up, is they want to know the equation of the tangent line, right? 4x plus 1, y equals 2x minus 2. So the equation of a tangent line is going to be the equation of the straight line that's this tangent line. So can you imagine if you draw the tangent line, it does have an equation, doesn't it? It's a straight line, it has an equation. And we're going to find it. So how's that going to work? Well, it's going to take only 2 steps. Step 1 is we are going to find the slope of the tangent line at x equals 2. Okay. Now, can you imagine that we did all of this hard work here and we got the answer? Since it's 2a plus 3, is it okay for me to say that the slope of the tangent line then would be 2 lots of 2 add 3 would be 7? Can you imagine we did the work and we got it? Right? 2 lots of a, 2 lots of 2 plus 3. Right? If you didn't have this guy, wouldn't you just use the limit as h tends to 0 or the limit as x tends to 2, you know, method 2, and you'd eventually get, trust me, you'd get 7, right? Just cutting out the middleman. Step 2, if you know the coordinates of a point and you know the slope of the line that passes through that point, shouldn't you be able to get the equation of the line? Now, I'm going to call this guy x1 and I'm going to call this guy y1. And there is an equation that you probably got in Math 94. It's called the point slope equation of a line. And it tells you how to get the equation of a line that passes through the point x1, y1 with a slope of m. Let's get the cobwebs going. Has anybody got that in their head? Can you remember that formula?
Is it y equals mx plus b?
Say again?
Is it y equals mx plus b?
That would be correct, Isaac, if the information had been the y-intercept and the slope. And that is what... So what's this one? Yeah.
What were you calling the x and y coordinates again? X1 and y1?
Y1, yeah.
Yeah, okay, then it would be, hold on, wait, I got this. Just using the equation, which is 2x plus 7. Wait, I mean 7?
No.
Wait, I'm sorry.
Okay, what
Wouldn't
I'm
it be
asking for
y
right
minus
now is
y1
the...
equals m parenthesis x minus x1?
Perfect, that's what I was asking for. Only the
Okay,
equation that you use to get the equation of the line, or only the formula, how about that? The formula that you use to find the equation of the line. Was that you, Kathy, that did that?
Yeah, it was.
You get some brownie points here, but I may take some of them back. Did you look it up or did you know it?
I did not look it up. I dug deep into pre-algebra for that one.
Okay, so does this ring some bells now? Can you remember this formula? So what you're going to do is y take away 8 equals 7 x take away 2. And that's going to be y take away 8, 7x take away 14, add 8 to both sides, and there is the equation of the tangent line. So this red line, this tangent line, has the equation y equals 7x minus 6. Let's check it. So I'll go to my calculator. Desmos would be better, but I don't have the time to load it up, so I'm just going to take this. The curve is x squared plus 3x, take away 2. And the tangent line should be y equals 7x, take away 6. And I'm going to go to the window. Since I'm only interested in the tangent line at x equals 2, right? Because the coordinates are 2, 8, but the x coordinate is 2. Since I'm only interested in that, I'm only going to do my window from 1 to 3. How about that? Now, when I do zoom 0, zoom to fit, can you see the curve in the tangent line? Maybe I should move back a little bit. Maybe they're just not enough going on here. There's -1 and 4. Let's try that. Right, there's my curve. Yeah, that's a little bit more convincing. Would you agree I've just found a tangent line? See, right there? And that's this guy. And I bet you that point where my finger is, I bet you that's the coordinates 2, 18, right? Now, suppose I screwed up, not that I ever make a mistake, and got maybe my sign wrong. You could use the calculator to check. Watch what happens when I graph it now. Would you agree that straight line is definitely not a tangent line to this curve anymore? It's quite separate. So you could check your answers very simply on a calculator, especially for tests. WebAssign just tells you you're wrong, but it'd be nice if you could check, in which case you wouldn't even type this in to WebAssign. Won't you go and figure out what your mistake is and call it good? Do you like that technique? This just calculating the equation on a tangent line. Thing to tell you here that's a bit of a truism, and it kind of popped up here. I asked a piece of information that was probably first given to you way back in Math 94, but you might have done it in Math 99 and maybe even done it a couple of times in 141, for instance. Anything that you've learnt in math, anything, doesn't go away. Have you noticed that factoring is here? When did you start factoring? Again, probably Math 94. Equations of lines passing through a point. Quadratic formula, you know, that minus b plus or minus guy. That trig identities like sine squared x plus cos squared x is 1, right? All those kind of things. They do not go away for your, depending on how much math you're going to do in your life. Pretty much anything you did from Math 94 can and will appear now and again. So this question here, where you're finding the equation of the tangent line and you needed to use this equation, you might only see 3 questions and then it will disappear. And then 4 weeks from now, it will reappear one more time. And then it will disappear for 6 months and you won't see it until maybe you do something in Calc 3 and suddenly you need to know it. Or the quadratic formula just appears out of nowhere for one particular question. So don't get into that habit of, I've done it, I got my grade, tick the box, lock the door, anything inside there, I can't remember it. Because that's just going to make your life painful. So I'm going to show you a shortcut. I'm going to show you a trick. And I did it with the other class and it actually worked out quite well. So I'm going to try it this way. I'm going to give you a function. And then I'm going to tell you what f dash of a ends up being. And one of my students went and said something quite interesting. She was saying, I noticed when I was doing the questions that there was a kind of pattern there, and I was just wondering, I wonder if it's true or not. Well, let's see if we can figure out the pattern. I want you to imagine you're the first people to do calculus, right? You've got it and you start playing about with it, and you'd like to see if there's a shortcut to getting the answer to polynomials. I'm only showing you polynomials. And this shortcut is going to be called, in pretty much every textbook I know of, is going to be called the power rule. So here goes. If the function is x squared, The derivative is 2a. If the function is x cubed, the derivative is 3a squared. If the function is 10x to the 5, the derivative is 50 a to the 4. If the function is 3x cubed, take away 2x squared plus 7x, add 1. The derivative is 9a squared, take away 4a, add 7. And you look at those guys and you scratch your head and you say, there's a pattern here. There's something going on here. And if I use that pattern, I should be able to figure this answer out without having to spend half an hour doing one of these big long x tends to a or h tends to 0 guys, right? So here is the tester. If you see the pattern, you should be able to tell me what the derivative of that guy is. I'll take a volunteer whenever you feel comfortable. Just tell me what.
40x cubed minus.
Stop.
Wait.
40x cubed, not quite right, almost right.
Hold on.
40, not x cubed. 40.
40a cubed. Sorry.
A cubed. Okay.
Yes.
Keep going.
40a cubed minus 12a squared plus wait.
Good.
3?
You're there.
Plus 3?
Yes. Now, at least one person to get that right had to know the pattern, right? You'd be a fluke if you guessed it, right? Let's do one more. I don't want to tell you the rule until you've at least tried to figure it out yourself. Corbin doesn't need to. He's already figured out what the rule is, right? So he's good. So somebody else I would like for this one. Corbin's not allowed to answer because he knows. Someone else.
Would it start out with 12a squared?
You are right. Oops. I'll stick to blue. You nailed it. Keep going.
Just 2x or 2a
Almost. Plus or minus.
minus.
Correct.
And then plus 7.
Correct. And stop. That's finished. So what is this thing called the power rule that allows us to take expressions like this and find their derivatives without doing all the hard work, right? Now, you can certainly, if two of you have figured it out and probably a few more and you're just too shy to tell me, this is one way to say it. It's the way I say it anyway. The rule is multiply by the power and then reduce the power by 1. So in English, multiply by the power and then reduce the power by 1. Okay, let's show you how that would work then. So suppose I had 5x to the 8 plus 3x to the 4 plus an x squared plus a 7x plus an 11. For each one of these terms, I'm going to use the power rule. The last two, the 7x and the plus 11, are kind of special cases. But all the other ones, it works really well. Multiply by the power. 8 times 5 is 40. Reduce the power by 1, and then just remember it's 8. You see where that came from? Multiply by the power, reduce the power by 1. Right, next one. Multiply by the power, you get 12. Reduce the power by 1, you get a cubed. Multiply by the power, you get 2. Reduce the power by 1, you just get an x. X becomes an a. Special cases. 7x. That gets you 7. Okay, let's tell you why that's still the power rule. Technically speaking, couldn't you call x x to the power of 1? Right? Then if you multiply by the power, isn't 1 times 7, 7? And what happens when you reduce it by 1? Don't you get x to the 0? Isn't x to the 0 just a number 1? So plus 7. I just remember that 7x gets me 7. It's just easier to think of it as a special case. What about the numbers like the plus 1s and the plus 7s and the minus 20s and whatever? Do they contribute anything to the answer, or do they just disappear?
Disappear.
They just disappear. Now, just to prove to you why they disappear, because the power rule tells you why they disappear. Do you know the number 11? Can't it be thought of as 11x to the 0? Because x to the 0 is 1, agreed? So 11 ones is like 11 x to the 0s. Now, if you multiply by the power, don't you multiply by 0, and 0 times whatever it is kills it, right? It's gone. But again, I just remember that numbers, constants, just disappear, right? And 7x gets you 7. Where is the guy we did? We just did, a little while ago at least, x squared plus 3x take away 2. Using our new shortcut method, what will f dashed of a, the derivative of a, be?
2a plus 3.
And just to remind you, if I can find it. Remember all that work? Just to get 2a plus 3. We got 2a plus 3.
So is this a replacement to both of the methods you showed us,
Yeah.
or just the second one?
Both of them.
Oh, cool.
Because both methods, even if you see if you did that question as an h tends to 0 method rather than as x tends to a method, they both give you the same answer because it's the same question. You're just tackling it from 2 ways. We've now got 3 ways to do it. Don't we have the shortcut, the power rule? Now, before you go crazy and say, I'm using that, I'm in there. No, I'm giving you this as a little taster, and I'm going to allow you to do it, and you just have to be honest and make sure that you do it on the following questions. So I'm going to write down the questions that you can use it for. For starters, you cannot use this rule for square roots. It doesn't work. And you cannot use this for fractions. It doesn't work. We'll show you in the future how to deal, the shortcut, right, for those guys, right? So you're stuck with those, but you can use it, and I'm just going to give you the list of the guys you can use it for if you choose to. Give me a few seconds to find them. You can use it for question 5. You can use it for question 8. You can use it for question 11. And yeah, 5, 8, and 11. Now, you don't need to use it for 5, 8, and 11. If you want more practice, h tends to 0 or x tends to a, right? If you want to get just more practice, you can certainly do that, and it will definitely give you the right answer. But 5, 8, and 11, you can use the shortcut.